Hi, my name is Thomas Gore, and today I want to show you two different types of data loading strategies in Qlik Sense. Let's assume we have following requirement from customer. A customer wants to have an extension developed which shows all data regarding a current selection. And for this extension, for example in a list box or a data table, it is a must to load all data first and then show them to the client. So this means if you have a big amount of data, for example 100,000 data rows, all of them need to be loaded first and then be visualized to the client. And to achieve this issue, you have two different types to implement and two different strategies to go. But first of all, I want to show you a minor extension I have developed for this example, which measures the time it takes for each of those two strategies. Those strategies are app.createCube, and this function can be found in the capabilities API, more precise in the app.API of Qlik Sense. The second one is backendApi.getData, and this can be found in the backend API of Qlik Sense. So what we can see here is a Qlik application with some demo data, and we can see that for the current selection there's a total row count of 100,001 lines. This means for the one dimension we have set here the trends ID and the three KPIs. There are in total 4 columns, one dimension and 4 measures. And it doesn't matter which strategy you choose. For each data fetch to the Qlik engine, you just can get from the Qlik engine an amount of 10,000 data rows or data cells, to be more precise, on each data fetch. So if you want to get 100,000 data rows for 4 columns, which means in totals that we have 400,004 data cells. This would mean that we need to fetch 41 times to the engine to retrieve all data. And what we can see here in this extension is how long it took with the current strategy to receive all the data. So I can go to this property tab, data paging type here, and change from app.createCube, which took about 5 seconds, a little bit more than 5 seconds, and change this to backendApi.getData strategy. As soon as I change this, we again get all the data, fetch all the data from the engine, and this goes a lot faster, as you can see here, just about 3 seconds. So again, to show you the difference, app.createCube takes about 5 seconds. And if I change back to backendApi.getData, it just takes about 3 seconds. So there's a difference of 2 seconds to fetch all the data from the engine. But if we take a look to the documentation where we'll go later on, both functions require probably the same, or let's say they require the same properties, so the same parameters, and they also return the same data. But why does the createCube function take that much more time than the getData function? To show you what happens on both strategies, I want to go back to the presentation and show you what happens when you call the backendApi.getData method. So let's assume again we have one dimension, 3 KPIs, and 10,000 possible rows to show. This means that we have in total 4 columns multiplied with 10,000 rows equals that we have 40,000 data cells to fetch. But as I said before, it's only possible to fetch a maximum of 10,000 data rows for each fetch. So this means that we need 4 fetches. And what happens within these 4 fetches will be shown here. First of all, if you do a selection, the engine calculates a cube. It's so-called a hypercube. And within this hypercube, are all calculated data regarding your current selection. And as soon as you start fetching the data, the engine sends you the several cubes. Just cube slices. Let's call it cube slices. Each slice is as big as 10,000 data cells. So all those slices are now sent to the client. But what happens when we use app.createCube function? We have again the same situation, 1 dimension, 3 KPIs, and in total 40,000 data cells. But there's a small but major difference that we can see here is there's not just 1 cube, there are 4 cubes and 4 fetches. But why are there 4 cubes? So just to visualize this, again, the engine calculates a hypercube. All data are inside this hypercube. So all 40,000 data cells are within this hypercube, and then sends the slice with the size of 10,000 to the client. But for the next slice, the 10,000 to 20,000 rows, the engine recalculates the same cube again and then sends them to the client. For the third slice, there's the same recalculation, then sent back to the client. The same for the last hypercube slice. And this is the major difference why it takes so much longer time using createCube than using the getData function. And why is it working like this? I can answer you this question. So let's take a look to the documentation of the getData function, which you can see on the left side, and the createCube function, which you can see on the right side. So again, here we are on the help side of Qlik Sense. This is the API reference, and we are located to the backendApi.getData method. On the right side, we are on the capability APIs, where we can find the app API and the createCube method. They look quite the same. backendApi.getData requires a queue pages, and createCube requires a queue hypercube def. So for now we are okay, we are familiar with the situation, and what we can see in the example is this backendApi.getData is called with a request page. So, and this request page we can see here. What this request page does is it has a queue top, queue left, queue width, and queue height property. And what you define with this is the exactly position of the cube you are looking at. Queue top means please start at position 0, for example, and then give me 10 columns, or in our example just 4 columns. And queue height means the size, the vertical size of this cube, which is in our example 2500. So if we take a look to documentation of createCube on the right side, we also can find queue top, queue left, queue height, and queue width too. And there are some other options. And the main difference here is that we have on the left side just a request page, so give me exactly this page or this hypercube slice. On the right side we see queue dimensions, queue measures, and so on. So this is in our example already included in the backend API. What you can do here is just create a fully new cube. So for example, get another granularity of your data by setting additional dimensions and so on. But again, we are just looking at 100,000 cells. And why does it take so long? So on the right side, you would need to implement a logic to iterate over the createCube function and receive all those functions. On the left side, the same. We need to iterate over the request page and give the information to the engine, where we say, okay, we have received line 0 to 10,000 and now we want to have 10,000 to 20,000. But what happens on the right side in createCube is on each app createCube, as the name says itself, we create a fully new hypercube. And this means that the engine needs to recalculate the whole selection, which could take a lot of time, and then slices the cube and sends you just one specific slice. In the next iteration, it again recalculates the whole cube and then slices it and sends it back to you. And how does it look in the code of the extension? I can show you here. I've built a small example which is also available on GitHub and will be linked in the video. As starting point, I defined traditionally the paint method, and what I am doing here, I have defined in the settings data paging options, which you have seen before, backendApi.getData, app.createCube. This is the drop-down box from the property panel I have set before. And regarding the value you have chosen here, the extension takes a look to the data paging type. Either it's backendApi.getData or it's app.createCube. And first, let's take a look to backendApi.getData. I created a class, which you can find here, backendApi.getData, and there are some methods, functions. For example, calculate request page. In this page, I calculate which request page I want to receive the next time. Then there is a helper function, count temp rows, which is just for the visualization on the front end to show you how many rows have been loaded yet. But the very important part you can find here, get data back by backend API. And what's very important is this section. So here I am calling this.backendApi.getData with the current request page. What I receive is a promise, and within this promise I get data pages. And data pages means in this case there is a specific hypercube slice included. And if I want to get the next slice, I again call this .paint, so it's a recursive call of the paint function where I set the layout and the element, which are the native parameters which the paint function receives or just supports here. And what it does, as soon as I call get data, I receive data pages, and those data pages are then set by itself to the layout property of the paint function. So this means that all data are stored to this.layout, and what you can find here, it's implemented in the count temp rows. Within the layout you can find the QHyperCube, and within this hypercube you find the data pages, and the data pages are called by me the different hypercube slices. What you can then do is iterate over those data pages and just retrieve all those data. And just to show you how the app.createCube function works, again, here's a class app.createCube function, and what's important here is the get data by app.createCube function. Again, we see a data fetch property with qtop, qleft, qheight, and so on. And I'm building my very own hypercube dev. But what I'm actually doing is just copying the hypercube definition of the current extension. So get all the dimensions, get the measurements, get the sorting, and all the other properties, and then define the data fetch section. And what I need to do now, and where I've been struggling with a long time while implementing this solution, is this asynchronous CreateCube. Yes, of course, the backend API get data is asynchronous too, but you need to take care with several issues, which I will show you later on in the extension again. We call app.createCube, give the cube the engine the hypercube definition, receive a callback, and then additionally I wrapped a whole promise around this function. And what can get you into a struggle is the recursive call of the get back data by app.createCube. Because let's imagine, like in my requirement, you need or you must load all data first. Then you of course need to implement some loop or recursive call to call all the CreateCubes. Because on each CreateCube you need to take a lot of care to the racing conditions, because if you won't fire them synchronously, which I implemented with this promise function here. You can get a lot of struggle that the first cube comes after the fourth cube, for example. So this needs to be verified in your code here. Again, let's imagine if the cubes are fetched, so which takes a time about 5 seconds, like in our example, and while the cubes are being fetched, you take another selection. With backendApi.getData, you have no trouble with other selections while the engine is calculating, because the paint function takes care of it automatically, so it's some magic in there, and you do not take care about any racing conditions. As soon as you implement like in my example, where you iterate or recursively about all those cubes, you would need to take care about the current selection states, because there you could get a lot of trouble. But to come to a conclusion, let's go back to my presentation. We see some pros and cons. And in the backend API, we have two major pros from my point of view. So you have no calculation overload of the Qlik engine. So what I mean in this case is the cube is only calculated once, and then you can get the slices and do not overload the whole engine. And yeah, in my second point, I say quietly the same. Only one hypercube for each selection and each object is calculated. And what are the cons of the getData method? Yeah, for now, I don't find anyone. There are no real contras of using getData method. And what about the createCube function? There are some pros. It's very useful for fetching different data structures and combine them in one extension. For example, let's assume you want to get a hierarchical data structure, for example, like a pivot table. And then for each line in this pivot table, for each different aggregation, you want to fetch exactly one line of a flat table. This would mean that you could probably implement the pivot table with the getData method and then load additional data, but with a different aggregation with the createCube function. And for this example, the createCube function is probably perfect, because you can specify your very own dimension, structure, measurements, and so on. You can create a completely different hypercube within the same extension object. But there are also some specific contrasts. For each cube or for each data fetch, this function creates a new cube. So this would impact the Qlik's performance very high. And developers, of course, need to take care about racing conditions in here. And just to show you an example about these racing conditions, because I did not implement such a racing handling in the createCube function, let's load all the data again. And now I go back to the extension and just let it run until it has finished. And what I will do now is just take a selection and again select other things, and now